artificial Earth satellites have become inevitable, an integral part of the global economy. There are ample examples for that. So, but when it comes to space, having a space program, having a formidable or a significant capability in the domain of space, it is not easy. Even Iran has launched a satellite. That is different. South Korea, North Korea, they have all launched. But the thing is, that is different. Only once or twice they have launched very small satellites. But there are only 6 countries which have the capability today to systematically launch large satellites in their own rockets and conduct space programs methodically, in fact. Okay, these countries are the United States. Now China has become number 2 almost in the sense, and Russia, then Japan, and France, I always say, but people say it is part of European space program. But Europe is not a country, Europe is a continent. But anyway, they have a European Space Agency which conduct this space program. So that's the way it is. And so 6th country is India. So all these countries have a significant capability in the domain of space. Take the case of India. Why India is a major spacefaring nation today? Because India today has the capability to design, develop, and build satellites. For example, here a satellite is being built, a scientific satellite called Astrosat is being built in ultra clean environment. You see the kind of people who are working there with the satellite, they look like scalpel wielding surgeons in an operation theater. Such amount of cleanliness, such a degree of cleanliness is very much essential for building some of these satellites. So India has all the infrastructure for building this, a variety of satellites, and it has got the facilities to test them even. In fact, it is not easy to build such facilities, but India has all these things to design, develop, build, and test satellites. In fact, in one building, a satellite in India can be assembled, okay, and it can be subjected to an array of tests, whether it is vibration test, acoustic test, or even thermo vacuum test, okay, many such things, electromagnetic compatibility test, okay, all these things can be done, okay, under a single roof. That is the capability of India. It is in Bangalore near the Marathahalli ring road. Actually, it is called eyesight. So India has all these capabilities built in the past few years. It is not that it is not there, but now it has achieved the status in which under one roof everything is there. A satellite can be assembled and tested and can be taken to the launch center directly from here. So that is the capability of India today. And of course, to launch. Till now, India has launched 77 rockets capable of launching satellites. 77 times it has launched rockets capable of launching satellites into orbit. That is the kind of thing. And 2 advanced technology initiatives are also there. So I'll come to that. So 77 is not a small number. Britishers who were ruling India have conducted a satellite launch only once, the 2 from Australia, 1971. Okay, and India has launched British satellites. Okay, and it's not only that launching satellites, of course, which is very important, and it's a very significant thing indeed. Besides this, India has the capability to keep satellites under firm control in their orbit using ground systems like this. For example, this is a fantastic antenna as part of Indian Deep Space Network. I'll come to that a little later. And it has got world-class control centers. When I see this control center, I'm reminded of the Jet Propulsion Laboratory in Pasadena, California, which is controlling many things, including the next Mars rover also will be controlled, which is speeding towards Mars, is controlled from there. So we too have a control center in India, that too in Bangalore, in Pune, which is second to none. Then Indian spacecraft, Indian robotic spacecraft have gone towards the moon and Mars already, in fact, and they have explored it very well. and one spacecraft called Chandrayaan-2 is exploring Mars, exploring the moon even today, and the Mars orbiter spacecraft also is exploring Mars. Then you can see three satellites called DMC-3. They were British satellites. They were launched from India a few years back. Okay, so this is the way it is. India has today not only capable of making its own requirement fulfilled, at the same time it is providing commercial, it is providing space services on a commercial basis. Yes, this is yet another capability of India, which has added yet another dimension to its capability. And of course, India today has got its own regional navigation satellite system. It's a standalone system, nothing to do with GPS. It is called IRNSS or NAVIC. Okay, that's the thing. And these are all the latest developments. I told you, this is one of the things which has come into effect very recently, NAVIC. And today we have got a high throughput communication satellite called GSAT-11, weighing, at the time of its launch, it weighed nearly 5,800 kilograms. Believe me, when it was launched, okay, when it is in orbit, it is generating nearly 13 kilowatts of electrical power. Compared to that, our first satellite, Aryabhata, barely generated 47 watts. That is how, this is one of the measures, I would say, as to how far we have come up in the domain of space. And of course, we have the so-called Earth observation satellites or remote sensing satellites today, which are capable of detecting features as small as a meter or even a little bit less from a height of nearly 600 kilometers. Okay, we have an array of remote sensing satellites today. So this is not a small capability. And earlier in the past and even today, other countries are also using our remote sensing satellite capabilities. And of course, in 2019, India launched Chandrayaan-2 with an orbiter, okay, an orbiter here and a lander, and inside that lander there was a rover. Okay, Chandrayaan-2 mission was carrying the orbiter, lander and rover. Orbiter, even today, let me repeat, it is working very well and it is exploring the moon with its array of instruments. But the lander, when it tried to soft land on the surface of the moon, till the end everything was fine. A few kilometers above the surface of the moon, it could not be accomplished later. So India is yet to accomplish a soft landing on the surface of the moon. And so, since soft landing could not be achieved, the rover called Pragyan, which was there, could not reach the surface of the moon safely. And anyway, yet another mission is being thought of regarding this. And of course, this is the one of the most successful stories of the Indian space program, called Mars Orbiter Mission, a spacecraft which was built to last for 6 months in an orbit around Mars, is working even after 6 years. This speaks volumes for India's space capabilities today. And of course, in the recent years, India's the most sophisticated and the most capable rocket, Gslv Mark III, okay, weighing nearly it is capable of putting 4-ton satellites into GTO. 640 tons the rocket weighs, in fact. And this is yet another development, the success of this rocket, as well as especially the upper stage of Gslv Mark III here. Whatever you are seeing here, this black colored thing contains a cryogenic upper stage, okay, which uses cryogenic technology. It uses a particular kind of a cryogenic technology called, one is the stage combustion. That was a different kind of technology. This is yet another type of technology, which is also cryogenic, and it is easy to test the components. And of course, it has advantages and disadvantages. But anyway, this is a fully indigenous one, and this is the one which has achieved success, and 3 times it has worked very well. So this is yet another development in the past few years as far as the Indian space program is concerned. This is called gas generated GG cycle engine. Okay, I'll tell you about it a little later. And of course, Shri Sudhindra also was mentioning about, aerospace domain. What is air and what is space from the ground? We are going up. That's the way it is. Nowadays, there is no such thing as air and space. Okay, they are merging slowly into aerospace domain. In fact, one of the developments in the domain of aerospace to occur in the as far as Indian space program is concerned is the development and first testing of a subscale model of what is known as RLVTD, Reusable Launch Vehicle Technology Demonstrator. This is a 1/6 scale model of the proposed reusable launch vehicle, which was tested on May 23rd, 2015. Okay, it is a winged vehicle capable of coming back to Earth and being used many times. That's why it's a reusable launch vehicle, but this is a subscale technology demonstrator. Much is yet to happen. This is the launch of RLVTD on May 23rd on board the first stage of our first rocket SLV3. That's the thing. And of course, the thing is coupled with the reusability of a launch vehicle. Elon Musk's Falcon 9, how it comes back and lands. That's a different kind of technology. Reusability is one thing. At the same time, if instead of conventional rocket engine using 70% of its propellants as oxidizer, carrying it, which is very heavy, if you were to use atmospheric oxygen and to work efficiently at hypersonic levels, it would be very good. So the space becomes more accessible. The cost of launching satellites will also come down. So that is why a technology called scramjet, okay, scramjet technology demonstrator was also tested successfully in 2016. This is yet another development which has taken place, okay, in the Indian space program. Of course, now I told you latest developments, what kind of satellites, what kind of planetary spacecraft that have been sent to other celestial bodies of the solar system, as well as what kind of propulsion technology and advanced technology initiatives that have been fructified in the Indian space program over the past few years. I told you Indian space program, the story of it and the evolution of the Indian space program is a result of a clear strategic thinking. Strategic in the sense I'm using in the word, it is a well thought out strategy. That's what I'm telling. When India became independent in 1947, within a decade, it had many problems. Economic, political, social problems, scientifically and technologically, there were many challenges. Okay, there were many disparate groups, many things were there. It was struggling, even it could not build a car. Forget about a car, even bullock carts at that time, they were not very efficient in the sense. That is the way it was. But at that time, one person by name Dr. Vikram Sarabhai thought of, okay, he dreamt of having a space program for India. That's what people were thinking in advanced countries as well as within India itself, because space flight and space related activities were an exclusive preserve of superpowers of the day, that is the United States and the Soviet Union. Even Europe was catching up. At that time, if India were to say, we want to have a space program, really people thought, I think it is too much for India. Okay, but anyway, Sarabhai, with his very good connections, and the thing is, with his clear thinking and his passion and with his conviction, he started the Indian space program under the aegis of the Atomic Energy Commission, which was headed by Bhabha at that time. Okay, Sarabhai very clever, in a clever way, he proposed to the United Nations that the thing is, India was ready to establish a sounding rocket launching center. What is a sounding rocket? This is the picture of a sounding rocket. A sounding rocket is a small research rocket capable of exploring the Earth's atmosphere, the magnetosphere, and near Earth space. It will go up in a ballistic trajectory and comes back. That's it. It is not capable of launching satellites. It is too small. But anyway, that was the beginning. India wanted to begin its space program with a bang. But anyway, Sarabhai, through his skillful strategy, he actually invited the United Nations to support this endeavor, and that is how Tumba Equatorial Rocket Launching Station was set up outside Thiruvananthapuram in a place called Tumba. Okay, why Tumba? Why not in North India or East India? Because geomagnetic equator passes through Kerala even today. Shifts here and there will be there, but it passes very near to Tumba. That is why several phenomena, including what is known as equatorial electrojet, could be studied. That is why Sarabhai went in for Tumba. And on November 21st, 1963, a sounding rocket called Nike Apache was launched. It was provided by the United States of America, NASA. Actually, that was carrying a scientific instrument built in France. That rocket was launched from the Indian soil from Tumba on November 21st, 1963. And that is the formal beginning of the Indian space program. And at that time, the thing is, many people question, why is it necessary for a poor country like India, underdeveloped country, they said. Then Sarabhai was very clear. He said, there are some who question the relevance of space activities in a developing country. To us, there is no ambiguity of purpose. We do not have the fantasy of competing with advanced countries in the exploration of the moon, the planets, or the manned space flight. But we are convinced, you remember what he told, but we are convinced that if we are to play a meaningful role nationally and in the Committee of Nations, we must be second to none in the application of advanced technologies to the real problems of man and society. What prophetic words these were at that time. That is the way it was. And even today, this is the mantra of the Indian space program. It is the ends ultimately to achieve overall development of the country quickly. Let us leapfrog. Okay, if we don't have good infrastructure, economic infrastructure, okay, it's a boon for us. It is an advantage for us, because we need not have to take the traditional routes taken by other developed countries. This was the thinking of Sarabhai. We can leapfrog into development using space technology. That was his unbridled belief, and even today, this is the one which is sustaining the Indian space program. With this, he began Tumba, and look at that. This is the way it is. Rockets were being carried on bicycle carrier like this. Today we have Gslv Mark III, which weighs, as I told you, 640,000 kilograms. That is 640 tons, which is as high as a 14-story building. But look at this. This is a part of a sounding rocket being carried in Tumba in the early 60s. And look at that. These two people, the thing is, when I joined the Indian space program, it was already just quite flourishing. Okay. And it had crossed its adolescence and early childhood also. It was tending towards maturity. So we had all the facilities in ISRO. But look at that. People who started work at Tumba, they had to sacrifice a lot in terms of food, in the sense many of them were vegetarians. And this vegetarian food, the kind of thing which they were accustomed to, was not easily available. Not that they were not available. It was not available, not easily available. So they had to go to railway canteen, eat, then take a circuitous city bus and go to Tumba. So no AC, nothing, no vehicles to move around, because the distances were very large in the rocket research center, in the rocket launch center. And look at that. This is one Sri Aravamudan, who is in mid 80s, tending towards mid 80s. He's very near to Malleshwaram. Okay. So the thing is, he's living in Malleshwaram near Sankey Tank today. And he was also a vegetarian, and this gentleman is also a vegetarian. Both of them, I don't know whether they have eaten properly, but they are struggling with a sounding rocket here. Okay, they are struggling with a sounding rocket. okay, to get it ready for launch. This is Mr. Arvomudan. Look at that. His face is also very sullen, probably due to heat, as well as, the thing is how much of food he has taken, I don't know. And fatigue is one thing. But anyway, what is there in his face is enthusiasm. My dear friends, his name is APJ Abdul Kalam. Okay, none other than Dr. Kalam sir, who was our president. He started his career almost with ISRO, because for a short while he worked in ADE, but he is one of the 7 persons selected for the Indian space program. So this is very interesting. Engineering students should note this. In fact, this is the way. Nothing comes at free of cost. Some sacrifice is required. Okay, then only things will work out. Okay, this is a sounding rocket by 1967. An Indian sounding rocket, that is a sounding rocket built in India called RH-75, took to the skies, and it was a significant development indeed. And I told you, Sarabhai thought of an Indian space program because he wanted to leapfrog. He wanted to make the country to leapfrog towards development very quickly. So, in addition to establishing a rocket launching center at Tumba, at Ahmedabad, he established a ground station to communicate with an American satellite or an Intelsat satellite. Okay, this was called SKS. Okay, this was under UNDP, United Nations Development Program. It was established, and many of our engineers were trained there, as well as the engineers from other developing countries. United Nations appreciated this like anything and gave further funds. And of course, in 1969, Indian Space Research Organization, the ubiquitous ISRO, was established. And the thing is, in the next decade, the India satellite program had, it blossomed, and India's first satellite, Aryabhatta, was launched in 1975. And of course, Sarabhai, before Sarabhai's death, he had signed an MOU with NASA, okay, on conducting an experiment called Satellite Instructional Television Experiment, which is the precursor to today's DTH. An American satellite capable of transmitting programs to TV sets directly, of course, using a bigger antenna like this, okay, was launched. Okay, it was about to be launched, and India came forward to participate in an experiment to telecast TV programs directly to the satellite. The experiment, this pioneering experiment, was called Satellite Instructional Television Experiment. In fact, that is the thing. And of course, this site program as well as Aryabhatta, they happened during the chairmanship of Professor Satish Dhawan, who provided the basic framework to the Indian space program, and even today that framework has sustained. Okay, the highest policy making body in India as far as space is concerned is the Space Commission, and under it, to implement the policy made by the Space Commission, Department of Space is there, and Department of Space implements the Indian space program through its operational arm called Indian Space Research Organization. And Professor Dhawan was the first person to become chairman of Space Commission, Secretary, Department of Space, as well as chairman of ISRO, and he is the man who has molded the Indian space program in its present form. I'll come to him a little later. And of course, I repeat once again, Aryabhatta was launched during his time. And of course, it was during Professor Dhawan's time, India became the 7th country to launch its own satellite. Okay, SLV-3, okay, was India's first satellite launch vehicle. On July 18, 1980, when it launched a Rohini satellite weighing about 40 kilograms into orbit, India became the 7th country to launch its own satellite to orbit. That is, launch a satellite using its own rocket. Okay, that's the thing. And okay, this is the concept of an orbit, especially geostationary orbit. And this is the orbit to which ATS-6, the American satellite, was launched. Okay, See, look at that. In the geostationary orbit, which is at a height of 36,000 kilometers, the satellite behaves, let me repeat, it behaves as though it is standing still over a particular area. Okay? It is not standing still, it cannot stand still. It has to orbit the Earth. So you can use it as a giant microwave relay tower, which is as high as 36,000 kilometers, and you can do wonders with it. And of course, this is the satellite instructional television experiment. The satellite signals for that were coming from the American satellite ATS-6, which was in geostationary orbit like this. And this is the precursor, or the forerunner of today's DTH. In my house also, on top of it, Tata Sky antenna is there, but it is a 1 to 1.5 foot antenna. And look at that. That is how technology has evolved. Okay. And of course, it was during Professor Dhawan's time, space came to be used for our national economy in a significant way, because before this satellite called INSAT 1B was launched, to talk to somebody in Chennai from Bangalore, you had to book a telephone call and wait for a long time, and there was no guarantee. But once the satellite was launched, within a few years, STD, IST booths proliferated like anything. Doordarshan, at that time only Doordarshan was there. That is, TV became a household word. Okay, and weather forecasting was the other field. I'll come to that. But anyway, Professor Dhawan not only excelled in formulating the Indian space program and implementing it, he was capable of recognizing the talent of the people. He recognized the talent of APJ Abdul Kalam, as one of his disciples put it, as the master coordinator. That is why Professor Dhawan made him the project director of India's first satellite launch vehicle, SLV-3. Here is Shri Kalam, Professor Dhawan, as well as Mr. Srinivasan. Okay, you may not know him. Anyway, so the thing is, let me narrate an incident which has become a cliche. Not cliche, it has become too ubiquitous today. Everybody knows, but anyway, I'll repeat for the benefit of many students here. Kalam, remember, was the director of India's first satellite launch vehicle, SLV-3, and Professor Dhawan was the chairman of ISRO at that time. Okay, the very first attempt to launch a satellite in India's first satellite launch vehicle, SLV-3, was attempted on August 10th, 1979. It was not a success, only due to a small problem which was not noticed properly. Anyway, such things do happen everywhere, all over the world. So it could not inject the satellite to orbit. It seems, as Kalam sir himself has narrated, with a sullen face, he went to Professor Dhawan and told, "I'm sorry, sir, we could not accomplish it this time, but let me tell the assembled media people as to how difficult it is and actually what went wrong." Then it seems Professor Dhawan prevented him. No, don't do that. I am the head of ISRO. Okay? You are a project director. I am the one who is heading ISRO. Let me take care of this. Let me handle the media, he said. And while addressing the media, he coined a special phrase called partially unsuccessful. People say partially successful. So Professor Dhawan had an MA in English also. He coined a phrase called partially unsuccessful. That means it was a success. Still, he was telling. He was perfectly correct. Then, less than a year later, SLV-3 triumphed like anything and launched the Rohini RS-1 satellite into orbit. At that time, Kalam sir went to Professor Dhawan and said, "Sir, this time we have excelled. India has become the 7th country to launch its own satellite. But, sir, why don't you please do go and brief the media about this triumph of India. Okay? I'll be with you," he told. Then Professor Dhawan told, it seems, "No, after all, I am the chairman of ISRO. I have not done anything for this. You are the project director. You are the people who have led a group of people to achieve this on behalf of India, for India. You should go and brief, not me. After all, I'm a titular figurehead, or I'm the head of the Indian space program. Look at that, my dear friends, especially students. This is magnanimity personified. This is what is needed. This is what is called as leadership. Okay, in management, this is what you see. Who is a leader? Okay, fifth discipline, there is a book. Okay, read in that. He defines very well in that. Okay, so the thing is, it is not only the skill, the capabilities of Indian space scientists are the people who have led them, not only their management skills, but their magnanimity that has been responsible for India's success in space today. You go outside the country. I have gone to many countries. ISRO means the kind of respect they have. I'm not bluffing this. I was in Greece. Greece is the cradle of Western civilization. 1.5 years back, I was there. When I was there, they were telling, why don't you Indians give your brains to us? They were telling. When our Chandrayaan 2 program did not go well, I was in a place called Thessaloniki at that time. People came to me, ordinary people, and said and consoled me, don't worry, next time you will do it, definitely. That is ISRO. I'm very proud to have worked for this organization for 37 years. Look at that. It was during Professor Dhawan's time, I told you, India's first satellite Aryabhatta was launched. So Professor Dhawan had a very, very, very able colleague in Professor U.R. Rao, Udupi Ramchandra Rao from Karnataka. He was, if Sarabhai is the father of the Indian space program or the architect of the Indian space program, Professor Rao can be, unquestionably, he can be called as the architect or the father of the Indian satellite program. Okay, and under his leadership, India's satellite program began, okay, in the industrial sheds of India. Believe me, in fact, a satellite is such a sophisticated device. A satellite has to work in the ambience of space where there is no air, there is vacuum, temperature excursions are too much, copious electromagnetic radiations, harmful electromagnetic radiations, and other particulate matter will be there. Okay, the ambience is totally alien to us. Not only horrible for human beings, it is horrible for even electronic systems also. But anyway, it's a miracle that all these things began in the industrial sheds of India. But today, as I told you, under one single roof, we can build a satellite, we can test it and take it to the launch center today. That is where it has, we have grown to that much. And of course, test facilities were very rudimentary at that time. And under the leadership of Professor U.R. Rao, a satellite called Apple was built. Ariane passenger and payload experiment, that was our first communication satellite, of course experimental, and it was tested, taken in a bullet cart and tested. This is not a, for PR purpose, this is not there. It is there for doing a particular test. Okay, so it had to be taken outside, but nowadays we need not have to do these kind of things. And of course, satellites, let me tell you what, you see, I told you earlier, Sarabhai conceived our space program for the overall development of the country to be achieved very quickly. Okay, so that is the reason why he conceived this space program. Today, look at the utility aspect of our space program. How many of you have thought about the role of satellites when you take money from an ATM? Okay, on top of on top of each ATM, you will see an antenna, a satellite antenna, what is so-called VSAT, very small aperture terminal. I'm sorry. So at the same time, on top of my house, instead of Airtel, it is Tata Sky. Many other companies are there. So satellites have become too ubiquitous. If somebody were to say live via satellite, people will say he is mad, because everybody knows that it is the satellite which has brought in all these things. Okay. Similarly, teleeducation, telemedicine. Okay, these are all the societal applications, because majority of our rural populace or majority of our population is in rural areas. If they want good education, good medical help, then satellites can establish connectivity between the patient and the super specialty doctor. So these two are the programs which are touching the lowest rungs of the society. And so is the case with weather forecasting. Today, our satellites are providing very excellent services in terms of predicting weather. They are not predicting the weather, they are providing valuable inputs. It is the onus of responsibilities on us to use the data to analyze it and generate forecasts, and it is being done. There was a time when thousands of people used to get killed during a cyclone, but you see nowadays a handful of people only die thanks to satellites. Okay, in the sense, instead of thousands of people, the number has come down significantly thanks to the role of our satellites. That is what I wanted to say. And India is a world leader in yet another domain called remote sensing. Remote sensing is the art and science of collecting information about a phenomena or an object without having any physical contact with it. You put a powerful camera in the satellite and make it to go around the earth in a polar orbit so that you can see the entire earth. You can see it. See, in one pass it is passing over India, next pass it is passing over Saudi Arabia. Like that you can see the entire world. And my dear friends, please be informed that India is a world leader in the domain of satellite based remote sensing. We have built more than 2 dozens of remote sensing satellites, and we have at present about more than 10 remote sensing satellites which are working, and the information provided by them not only is being used in India but even outside India. That's what I would like to say. And this is the type of picture. This is the type of picture which comes from a remote sensing satellite. Okay, remote sensing satellite. I and you will marvel at this picture and say this is very good, but a trained geologist or a resource scientist can identify many things. What is the acreage of a crop? What is the yield of a crop? Many things. For example, how to find the groundwater and what is the pollution level, as well as how about the finding schools of fish, shoals of fish in a particular area. All these things can be estimated, and it can be known by analyzing the pictures taken by remote sensing satellites. And of course, that's why many fields, including groundwater prospecting and agriculture, forestry, all these fields have been immensely benefited. And such works have been institutionalized in India. Prime Minister Modi ji has told, say, space technology should be used to the maximum extent for the governance of the country, and it is being done even today. And of course, India has a standalone navigation system called IRNSS or NAVIC. We have 8 satellites. All the 8 were built in India, ultimately in Bangalore, and launched by our own PSLV. And now this is fully operational system. Okay, but the difference is it has all the facilities provided by GPS, the ubiquitous GPS, but it is regional, not global. That is, the India and its environs are the operational area of this. And of course, if you are traveling on the road in India or nearby India or in the ship or in the air, you can know your position, your speed and direction, as well as time properly and accurately using our NAVIC system. And of course, this slide I showed earlier in the beginning is one of the finest scientific satellites today in existence. It is called Astrosat, which was launched in 2015. It has got the capability to see in the visible, in the ultraviolet, in the X-ray region of the electromagnetic spectrum, as well as to a certain extent even in the gamma rays. So our earlier chairman, Sri Kiran Kumar sir, was telling, somebody has done something. Is there anything for us to do? We should never think in India like that. There is always an ample opportunity for doing good science. I'll come to that. And of course, people say whatever goes up must come down, but it is not the case. As if you were to launch a satellite into a distant orbit, it may not come back. But anyway, satellites which are circling the Earth within about 500 to 1,000 kilometers, they will come back. But anyway, my dear friends, it is as much difficult to come back from space as it is to go there. Because the thing is, nothing comes at free of cost. When you are circling the Earth, you are circling the Earth at a speed of tens of thousands of kilometers per hour. And if you want to bring down your speed to zero, then you have to exchange speed with something else, which is the temperature. So you have to have a good heat shield. And India has done such a program called RLVTD, sorry, not RLBTD. This is a re-entry vehicle which we tested in 2000 space capsule recovery experiment. That is SRE is the name of this vehicle, which was launched in space for 12 days. It circled the Earth like a satellite, and it came back to Earth and landed safely. In the very first attempt, India was successful in this. And of course, we have tested a much larger spacecraft from space. It has come back safely again. And significance of that, I will tell you a little bit later in about 5 minutes. And of course, Indian spacecraft have gone towards the moon. This is Chandrayaan 1, which was launched by PSLV in 2008. And, it went to moon and started circling. And if anybody were to ask what India can do, this was the answer. India's first lunar mission finds water on the moon. That means before Chandrayaan 1, if some scientist were to be asked if is there water on the moon, he would have scratched his head and said, perhaps. But today he says certainly, because conclusive evidence for the presence of water on the moon was actually provided by our and your Chandrayaan 1. So good science can be done. Engineering students, let me tell you one thing. Even if you are interested in astronomy, you should know that an astronomical instrument on board spacecraft, it is not only physics which is there. The data has to be assembled, formatted properly, transmitted. That is electronics. And the boxes are mechanically fabricated. So many other disciplines, sub-disciplines of engineering will find work in astronomical instruments, in fact, and in building astronomical satellites. As I told you, space technology is a synergistic confluence of many engineering disciplines. So, if you are from different engineering disciplines, either chemical, electrical, electronics, information technology, computer science, whatnot, civil, even structural, thermal, okay, all these things are very much essential for satellites as well as for rockets. And of course, Chandrayaan 2, I told, this was a very, very challenging thing, but it will be taken up again. That is a soft landing attempt on the moon in Chandrayaan 3. And of course, let me tell you, this Mars orbiter mission spacecraft, from engineering point of view, I'm telling, not for high school students, from engineering point of view, it's a formidable challenge itself, because Mars, even when it is very near to Earth, it is at a distance of 6 crore kilometers. To go to Mars, it takes 10 months. Okay, how to navigate it, how to launch it. The launch window has to be very precise. Within 1 second, you have to launch. It was launched on November 5th, 2013, and 10 months it traveled in deep space, and it became a satellite of Mars, an artificial satellite of Mars, on September 24th, 2014. This was the launch of Mars orbiter mission. This was the day when Narendra Modi ji was there with us on September 24th, 2014, when it was put into an orbit around Mars. India became the first Asian country to reach Mars, and later, within 6 months, whatever others had not achieved, other space agencies had not achieved, that is scoring 100% success in the very first attempt to explore Mars. India and ISRO were the only country and the space agency doing that. NASA has explored Mars wonderfully, no doubt about it. Europe has explored, I'm not telling, but nobody had achieved 100% success in the very first attempt. So this is the case with India. And of course, this is the picture of Mars taken by your spacecraft, and it adored the National Geographic page, front page of National Geographic in 2016, November 2016. I could not control my emotion when I held it in my hand. Look at that. The article is about Mars, and much of it contains about the American space program. But the picture of Mars was taken, a picture of the globe of Mars was taken by India's Mars orbiter spacecraft. What else you need about India's capability? Okay. And of course, In the next 2 minutes, I'll briefly tell you about launch vehicle program. The very first step in towards launch vehicle development was through sounding rockets. I told you they are not capable of launching satellites to space. They are mainly solid propellant rockets. Okay, they were built in India first as a stepping stone towards satellite launch vehicle development. And of course, look at that. It is not easy to achieve orbit. A rocket might be enormous and it is too much of work has to go too precisely to achieve orbit. Okay, look at that. This is from Philosophiae Naturalis Principia Mathematica of Isaac Newton. In 1671, he had explained how to achieve orbit. I don't want to go into details into this because it is not a physics class. But let me say, if I say this many thousands of if I want to achieve orbital velocity, it is 8 kilometers per second. You will listen for a moment like a transient and you will forget it. But if I were to comparatively put it in a different way, I feel that it appeals to much more. Look at that. This is a happy family which is playing on our road in a TVS 50. What is their average speed? Their average speed is might be 25 kilometers per hour, not second, hour, 25 kilometers per hour. Then the thing is, you don't like that kind of slow speed. You go to a bullet train. Okay, it goes at nowadays not. This is from Shinkansen, Japan, but in China and France, many up to 500, 600 kilometers per hour you can travel. Okay, in speeding trains, and in this aircraft like this, a jet plane. Okay, traveling intercontinental distances, it is 1,000 kilometers per hour. In Concorde, which is not in service, of course, supersonic passenger airliner, you would have traveled at 2,300 kilometers per hour. And in this SR-71 Blackbird, designed by Skunk Work in the United States, you will travel at 3,000 kilometers per hour. And in this scaled composites space plane, okay, or even Richard Branson nowadays is proposing his own thing. It will travel at 3,500 kilometers per hour. This plane is not going to orbit. It is just hopping into space and coming back. 3,500 kilometers per hour. But my dear friends, to put a satellite into an orbit which is 200 kilometers high, even 200 kilometers high, you have to achieve a speed of 28,000 kilometers per hour. That is 8 kilometers per second. And it is not only the kind of acceleration, it is the kind of velocities, it is the kind of orientation control which is necessary. It is formidable, in fact. The kind of aerodynamic loads, the kind of structural loads, and the kind of thermal loads which are on the vehicle are mind-boggling. We cannot imagine it, okay, from the point of view of day-to-day life. But despite all these challenges, India has perfected 5 generations of launch vehicles. First was SLV-3, then now after ASLV, a mid stopgap vehicle, we have our pride of India, okay, Polar Satellite Launch Vehicle. And this is the one, you know, the thing is it has launched more than 300 Indian satellites, in fact. Okay, so not only not only Indian satellites, it has launched many foreign satellites, and of course, more than 200 in fact. And I'll show you a 2-minute video and look at that. This was when PSLV launched 104 satellites in a go, and look at that. This is from internet, it's available.
We undertook an incredibly complex challenge. We were launching 88 spacecraft in orbit. 5 is on. Here we are. Mission 1 where it all comes together. Now we're at the point where we can image the entire Earth every single day. And it's a new capability that humanity's never had before. single most important thing about that effort has been the team?
Which was just really that throw your hands up in the air and say, yeah, we did it.
That's what would get me through the day, knowing that everything I did contributed to mission one.
Our team is like an orchestra or a band. We're all rehearsing and practicing together to build something really amazing.
Our team is really close. We're kind of like a family, so it's just like very, very exciting accomplishment for all of us.
There's a huge range of uses for daily imagery, from agriculture to disaster response, to tracking deforestation, to helping with consumer maps, many different things.
I really think it provides a potential base layer of information and data that's never existed. The applications are really endless.
We have undertaken a minor Apollo project as a small company. I mean, we launched more satellites than anyone else in history.
Feels like a baby being born. It's unlike anything else.
Doing something like this is a lot like running a 4-minute mile. We've proven to the world that it can be done. Now what's next? Really, the reason why we're here is to put the data into everyone's hands and to change the culture.
We really deserve to pat ourselves on the back, and I personally wanted to say thank you.
Okay, you saw that, and when PSLV took off, lifted off from Sriharikota, people who were clapping were in the Bay Area near San Francisco, the so-called Silicon Valley there, in fact, and the rocket was ours. I told you, Indian space program began on November 21st, 1963 from Tumba, when a sounding rocket supplied by NASA called Nike Apache, carrying a scientific instrument provided by France and launched by Indian scientists took to the skies. That was November 21st, 1963, and 2017, February 15th was a red letter day in Indian history when 104 satellites were launched by PSLV. That was a record till a few days back, and because Elon Musk's rocket, 143 satellites it has launched, and our record has gone now in the past few days only. Otherwise, it held for 4 years almost. So, November 21st, 1963 was that, and February 15, 2017 was this event. That signifies how far India has come. Of course, India has got a more capable and heavier vehicle called Gslv, and of course Gslv Mark III is the latest one, capable of putting 10 10,000 kilograms into low Earth orbit, and that is the way it is. And it is a vehicle weighing nearly 640 tons, and these two solid boosters, they are known as S200s, and they just devour the propellants. Each one of them contains 210,000 kilograms of propellant, 210,000, 210,000, 420,000 kilograms of solid propellant is washed out in 2 minutes 20 seconds. It is the prodigal rate at which they consume the propellants. That is why I have fondly named them as Bakasuras. That is the way it is. That is how it generates the tremendous thrust. And of course, not only in rockets and satellites, India has excelled in the domain of satellite communication, ground infrastructure also. This is one of the best antennas built anywhere in the world, called DSN-32, with a diameter of 32 meters, 105 feet. This was developed here by Dr. S.K. Shivakumar, who headed KSTA earlier. Unfortunately, he died in 2020. Okay, it was 2019, sorry, and it was really shocking for me because I worked with him. I began my career with him, and this is an antenna which is having a high technology called 7-mirror beam waveguide system, because once the microwave energy gets into it, there is no cable losses are not there. Instead of that, a system of mirrors reflects the electromagnetic energy into a dichroic mirror. So this is one of the best antennas. It has proved itself during Mars orbiter mission as well as 2 Chandrayans time. So now the challenge for the Indian space program is Gaganyaan. Till now, whatever India has done in the domain of space, that is in launching satellites which are not carrying any human beings. Gaganyaan is India's first human spaceflight program. It was supposed to have been fructified in 2022, inevitably due to the corona, what can I say, scourge. Okay, the thing is, because of the effects of corona, some change essentially might be there. But anyway, this is one of the greatest challenges for the Indian space program. People who have studied engineering can, if they get a chance to enter ISRO, they can work in such exciting fields. Let me tell you, more capable satellites, communication satellites, meteorological satellites, remote sensing satellites, navigation satellites, scientific satellites have to be built. They have to be more efficient, and they are shrinking. Nano satellites, even pico satellites are coming, and small satellites, okay, mini satellites. They are all already, ISRO has launched such things also. Another thing is student satellites have been launched by ISRO, and new planetary spacecraft are being planned. I told you Chandrayaan 3, Shukrayaan, like that, such things are being contemplated. I'm not a spokesman for ISRO. This I have also read in newspapers and gone through the media outlets, and I'm telling you because I'm no longer with ISRO. Okay, as a passionate science communicator, I'm speaking to you. And of course, more capable and more efficient launch vehicles are being built. So if you are from any discipline of engineering, and of course, ground infrastructure also has to be further scaled up for India to manage its requirements. In fact, so if you are from any domain of subdomain of engineering, you have ample opportunities to work in the domain of space. So I would advise engineering students, okay, UG or PG, to have a look at ISRO website. Okay, there is a thing called About. You click on that, and careers, it will appear in the right hand side. You click on that, job opportunity it shows, and all the things pertaining to that are exhibited. Okay, so for the recruitment of engineers and recruitment of clerical staff, okay, it is done centrally. There is a central board for recruitment. Okay, ISRO central recruitment policies are there. Okay, there they recruit. But when it comes to other things like scientific assistants with diploma and such things, that they are handled at different ISRO center levels. So I would advise you to see the ISRO website. About, you go and click, then you go to job careers, and then job opportunities. You will learn a lot about it. You can always write to ISRO also. That is the way I would advise you. As far as my experience is concerned, all the 37 years I spent there was very, very exciting. I learned a lot. ISRO not only provided me salary, not only provided me job, it provided me education. Okay, you too will feel like that. Definitely, if you work in the domain of space, it is so exciting. Let me tell you, in fact, it is very, very exciting indeed. And India has proved itself that it can do things in space. Now, the country has been taken to a higher level thanks to its space program. Now, engineering students who are studying and who are going to come out, they can contribute in their own way, passionately, with dedication. Of course, facilities are there in ISRO. Everything will be provided. Okay, that is what was provided to me also. And you can take the country to still higher place in the domain of space. And thank you very much. Once again, I thank KSTA and Ms. Ramesh for Dr. Ramesh for providing me this opportunity, as well as the CEO of KSTA. And thank you very much. And with this, I'm going to stop this. And if there are any questions, I'm ready to answer. Thank you. Thank you very much.
Thank you so much, sir. Our CEO will come.
Yeah.
Participants, any questions?
Yeah, if you have any questions, you can ask.
Sir, one question.
Yeah, please.
how can budding engineering prepare to get into ISRO? What are the basic skill set required?
In my opinion, I can say generally only, not a kind of tutorial kind of thing. You see, when they have studied engineering, whatever fundamentals they have studied, they have to have a lot of strength in that. Okay, whatever domain they have studied, engineering in general and their subdomain in particular, knowledge of that basic knowledge, knowledge of fundamental is a must. At the same time, whatever is going on around the world, they in this domain a broad overview they should have. In fact, I think with that they can prepare very well for ISRO. That much I can say. In fact, I don't know anything about training and all those things, but to my knowledge of my association, with my knowledge of association ISRO, this is what is essential.
So any more questions, participants?
Any more questions are there?
Sir has nearly 4 decades of experience in ISRO. If you have any question related
Yes.
to space research, space education, now it is the time for you to ask.
Definitely. I think there are no questions.
The only question that was there, you have already answered, sir.
Okay, fine.
Sir, for space training, you already told about training in satellite remote sensing and space science. So, one more question now. Till now, anyone has gone to Mars?
I mean, unmanned spacecraft or uncrewed, not CRUD, CREWED. Uncrewed spacecraft only have gone. Elon Musk said, I'm going to send. People gave their names. I don't know how much of courage they have now. One way ticket to Mars. It is not easy. You know, Mars, when compared to all other bodies in the solar system, it is very similar to Earth. But still, let me tell you, if you stand on Mars in a shirt sleeve environment, either a pant and shirt if you wear and stand on the surface of Mars, our blood vessels will come to the extent of bursting and all the fluids in our lungs will come out because the atmospheric pressure on Mars is 1/100th of that on the surface of the Earth. No, it's not easy. So much is essential to make preparations before humans go to Mars. Anyway, all said and done, United States and many other countries are interested. Okay, China also says it, vaguely says it is interested. But I think that with the kind of state of affairs in the world, representatives of humanity, which may include Indian also, might go to Mars. Not as moon, Americans went to moon, Russians could not go, not like that. Representatives of entire humanity might go to Mars. That is the thing. They go. They might. That is what I feel.
Sir, one more question.
Yeah.
The current estimate for one-way travel to Mars is around 6 months. The current estimate for one-way travel to Mars is it 6 months?
No, it's not like that. It is not 6 months, or even you can travel quicker. But you know, every 27 months or so, Mars and Earth, their position around the sun, they align in a particular way that at that time, with minimum expenditure of energy, you can travel to Mars from Earth. Okay, alignment has to be proper around the sun. So it takes about 9 to 10 months, 8 to 10 months. You see, for example, last July, one spacecraft from UAE, one spacecraft from China, one spacecraft from USA have been launched. All of them are converging in February because everybody is taking almost the most efficient path. If you have enough rocket power, you can jump. It is not easy, but that much of rocket power is very difficult to achieve. With the present technology, it is highly wasteful. That is why months together are essential for now to travel to Mars or any other body. Not moon, of course.
Sir, can you please throw some light on colonizing Mars?
See, colonizing Mars means whether it is in the short term or the long term. Short term means, first of all, you have to develop more efficient propulsion to go to Mars, more capable and more efficient. Of course, China is developing a rocket and called Long March 9. And of course, more than that, Americans are SLS. There is a satellite launch system they are developing. And newer technologies, reusable technologies will also maybe scramjet propulsion kind of thing might come up, but they cannot be used from the ground. Okay, so all these things, and at the same time, how to manufacture rocket fuel, rocket propellants on the surface of Mars using the Martian atmosphere, and how to take oxygen from the rocks and converting it to breathable oxygen. Okay, and how to use the resources on Mars and build habitats on the surface of Mars. Problems pertaining to all these things have to be solved first. After that only one can think of establishing bases like the ones in Antarctica, and then only colonizing comes. Colonizing means it takes maybe thousands of years. And there is another field called planetary engineering, okay, or terraforming. That is, if we can convert Mars into a planet like the Earth, that will not happen in 10 years, 100 years, 1000 years, 100,000 years. It is not easy. Okay, that is called terraforming. But there are, so if we convert like that, then one can go and live there like on Earth. But anyway, gravity on the surface of Mars is only 38% of that on the surface of the Earth. That you cannot help it. So, but there are many ethical questions. So it is not in the near future, I would say. But anyway, one can be an optimistic. One can be optimistic in this regard.
Sir, can we bring helium-3 from lunar surface and use it as an energy source on the surface of Earth?
Yeah, one of the reasons for going back to moon is people say helium-3, no doubt about it. But when we bring anything from the surface of the moon to Earth, I'm very uncomfortable. Because you spend so much of energy going there, coming back, and all those things. Instead of that, you can as well establish industry on the surface of the moon itself or in an orbit around the moon. That is far more efficient than bringing minerals from moon or helium-3 from moon and all those things. Helium-3 is supposed to be a very clean fuel for the future nuclear fusion reactors which have not yet been designed.
Yes.
So from
Sir,
that
one more.
view, yeah, Heli, that is the thing.
One more question. Why aren't we launching satellites to other planets that are closer to Earth?
Why? We have launched
Kalsagideಲ್ಲ Mars ಗೆ.
Mars we have launched, and Shukrayan is one more thing in newspapers. ISRO announced that ISRO chairman told about Shukrayan. So in fact, the nearest planet to us is Venus. Okay, it is
Yes.
only at a distance of about 4 crore kilometers. Mars is at a distance of 6 crore kilometers minimum. Okay, so we have launched towards Mars. It's not difficult to launch towards Venus, but anyway, there are certain challenges. Okay, but anyway, yeah, there being, and some there were reports that on some asteroids also India is interested and all things, comets and such things. So plan will be there in future.
Yes,
Definitely, ISRO will think of that. I feel. I'm not sure about it.
Sir, is India trying to create reusable rocket?
That's what I told. We have tested what is known as reusable launch vehicle technology demonstrator. We are interested in developing reusable rockets because today the cost of launching 1 kilogram into space is prohibitive, maybe $10,000 or $20,000 per kilogram or something. If you can bring down that amount significantly, you have to reuse the rocket. Partially it is being done by Elon Musk today in Falcon 9. Okay, so all said and done, if you were to reuse it, you can improve the cost of access to space. So in terms of materials, you can make them lighter. Okay, in terms of managing the heat during the re-entry into the Earth's atmosphere, if you were to manage, and if you were to improve your guidance system for a precise coming and landing, and if you were to adopt scramjet technology, I told you that RLV, TD and scramjet both have been tested in the past 5 years. In the beginning, I told you. If you adopt these 4 things, yes, you can do. And India has already tested reusable launch vehicle technology demonstrator as a first step. But that vehicle is too small, 1/6 of the actual reusable launch vehicle. So much needs to be done, not only in India, in many other countries also.
So thank you very much, sir,
My
for an
pleasure.
excellent presentation. And also participants had many questions which you answered so well. On behalf of KSTA and on behalf of participants, I thank you immensely. And as I told earlier, we have a good training center in KSTA. We'll
Yeah.
be organizing offline physical trainings.
Fine.
We'll be inviting you for talk, sir. Thank you very much.
Pleasure. And let me tell you, to the students, really, I repeat, working in the domain of space is very, very exciting, challenging,
Yes.
at the same time satisfying also. Definitely. But the level of satisfaction, level of achievement, it differs. But overall, I can guarantee you it is very exciting. That is my personal experience. Not only that, I've seen people at different levels. I was a satellite scientist earlier. For 25 satellite missions, I worked. Okay, it was so exciting. When I went outside the country to DLR in Germany or a NASA ground station, I have seen this is the way they work. That's all. We are second to none. I'm not telling arrogantly, we only are the best. No, I'm not telling. We are second to none, I'm telling. So, if you were to enter ISRO, really, it's a very challenging to enter because of the requirements. If you were to enter, you have definitely, the thing is, the domain is so vast. You can work for many interesting projects. That's all I feel, because Indian space program has proved itself. There have been setbacks. See, it is like a child which gets up and tries to walk, it falls. Does it stop? No. It again gets up, tries, succeeds. That is what India has done in the domain of space. That is the uniqueness of the Indian space program. Even America has suffered like this. But for a country like us, it is not easy to accept that. But that risk was accepted, it was taken as a challenge, and we have triumphed. And the onus of responsibility of taking it still higher is for the current generation of students. They will be the ISRO people. Thank you. So
Yes,
let them consider it carefully and let them dedicate themselves to taking the country to much higher in the domain of space. Thank you. Thank you very much.
we are very proud of ISRO and its achievements. In fact, I am blessed for having worked with two legends, Professor U.R. Rao and Dr. S.K. Shivakumar. And in fact, Dr. Onegoda sir also has worked in ISRO. So in academy, we have built a culture of ISRO here.
That is very good. I work with both of them, Professor U.R. Rao, not much because I'm too young compared to him. And of course, you know very well that my career began with Dr. S.K. Shivakumar. He was like my elder brother, in fact. Okay.
Yes.
That is
We remember both of them always. They are the people who set up all this infrastructure for us to continue in the academy. We are grateful to them. Thank you very much for your presence in this webinar, sir. Thank you.
Thank you very much. I wish well for the academy to all of you. Namaskara. Thank you.
All participants, tomorrow the two more sessions are there. First by Dr. Uttam Kumar of IIIT. He will be talking on machine learning, and later Mr. Srinidhi will be speaking on data and analytics. Please do join by 10:45. We'll start the session exactly at 11 o'clock. Please do join. All the best. Thank you very much. See you tomorrow.
Thank you.
Thank you, sir.
Thank you.